Hello friends, the topic for today is Simple Reflex Agents in AI. The Simple Reflex Agents select actions on basis of current percepts, ignoring the rest of the percepts history. Simple Reflex Agents have the admirable property of being simple, but they have turned out to be of limited intelligence. Agenda for today's video: review of agent and environment concepts, the structure of agents, types of agents, Simple Reflex Agent overview, general program in schematic form for Simple Reflex Agent, and summary. Let us start with the review of agent and environment concepts. Agents interact with environments through actuators and sensors. The agent function describes what the agent does in all circumstances. Performance measure evaluates the environment sequence. A perfectly rational agent maximizes expected performance. Agent programs implement some agent functions. Performance, environment, actuators, and sensors. PEAS description define the task environment. So these are the concepts which we have seen in the last two videos. Then let us go to the structure of agents. The job of AI is to design an agent program that implements the agent function. That is the mapping from percepts to action. We assume this program will run on architecture, which is some sort of computing device with physical sensors and actuators. So agent can be described equal to architecture plus program. The program we introduce has to be one that is appropriate for the architecture. The architecture might be just an ordinary PC, or it might be a robotic car with several onboard computers, cameras, and other sensors. In general, the architecture makes the percepts from the sensors available to the program, runs the program, and feeds the program's action choice to the actuators as they are generated. The agent programs that we design take the current percepts as input from the sensors and return an action to the actuators. There is difference between the agent program which takes the current percepts as input and the agent function which takes the entire percept history. The agent programs take just the current percepts as input because nothing more is available from the environment. If the agent's action need to depend on the entire percept sequence, the agent will have to remember the percepts. So that is the basic difference between the two agent programs. Then let us go to the types of agents. Four basic kinds of agent programs that embody the principles underlying almost all intelligent systems. First is simple reflex agents, model-based reflex agents, then goal-based agents, and utility-based agents. Then let us go to the simple reflex agent overview. These agents select actions on the basis of current percepts, ignoring the rest of the percept history. For example, the vacuum agent shown in figure 1a and whose agent function is tabulated in figure 1b is a simple reflex agent because its decision is based only on the current location and on whether the location contains dirt. So here you can see we have two locations A and B, and the vacuum cleaner agent is present. Here is shown in the location A. Then here we have the table, so percept sequence and the action. So if it is in the A location and percept sequence is clean, then it will go to right, that means it will go to B location. Then if A comma dirty, that is the percept sequence, then the vacuum agent will suck. Then B comma clean, it will go to the left, that is to location A. Then B comma dirty, it will suck. A comma clean, comma A comma clean, again it will go to the right because it has completed its task in location A. Then A comma clean, comma A comma dirty. So once it get A comma dirty, it will suck. And in this way, the table will have the percept sequence and the action. So a agent program for this agent is shown here. The vacuum agent program is very small indeed compared to the corresponding table. The most obvious reduction comes from ignoring the percept history, which cuts down the number of possibilities from 4 raised to t to just 4. A further small reduction comes from the fact that when the current square is dirty, the action does not depend on the location. The agent function is based on condition action rule, also called the situation action rules or if then rules. As we can see here, we have function, reflex, vacuum agent, then there are two parameters, location and status, returns an action. So this will return an action. So if the status is equal to dirty, then it will return suck. Else if location is equal to A, then it will return right. Else if location is equal to B, it will return left. So this is a very simple program for the agent. The program in this figure is specific to one particular vacuum environment. Then let us go to the general program in schematic form for the simple reflex agent. A more general and flexible approach is first to build a general purpose interpreter for condition, action rules, and then to create rules set for specific task environment. Now figure 3 shows the structure of this general program in schematic form, showing how the condition action rules allow the agent to make the connection from percept to action. Now in this figure we use rectangles to denote the current internal state of the agent's decision process and the oval to represent the background information used in the process. So here these two rectangles that denote the current internal state of the agent. So what the world is like now. So this is one state, and what action I should do now, that is the another state. The oval to represent the background information. So here we are putting the condition action rules in the form of the background information. The agent program, which is also very simple, it is shown here in figure 4. The interpret input function generates an abstracted description of the current state from the percept, and the rule match function returns the first rule in the set of rules that matches the given state description. So that is how the program will work. Now here you can note that description in the terms of rules and matching is purely conceptual. Actual implementation can be as simple as collection of logic gates implementing a Boolean circuit. So in that way we can implement the actual agent. Then let us go to the summary. Simple reflex agents have admirable property of being simple, but they turn out to be of limited intelligence. The agent will work only if the correct decision can be made on the basis of only the current percepts, that is only if the environment is fully observed. So if the environment is not fully observable, even if a little bit of unobservability can cause serious trouble. So that's why we say that the simple reflex agents have limited intelligence. So with this we come to the end of this video. If you like the video, press the like button, share with your friends, and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon so that you get notifications for our future videos on this subject. And thanks for watching. Have a nice day.